4, 6, 10, 16, 24. So take the first difference. Notice that this is 2, this is 4, 6, this is 8. Well, we know it's not linear, so we take the second difference. The second difference, notice that this is going to be 2 plus 2 plus 2. Well, therefore, we need that our sequence is quadratic, right? It's a on the graph, right? Parabola. Now, it's not going to be a straight line, so we're going to once we know it's quadratic, because we took the second difference, and it's 2, 2, 2, we're going to take that 2 and divide it by 2. We get 1. So the coefficient here is 1. Now, most of the times we're not going to write it. We're just going to, there's no need to write the 1 there. What does an n squared sequence call? Well, if I asked you to take n squared and plug in the number 1, 2, 3, 4, 5, well, 1 squared would give us just 1. 2, replace the n would be 4, right? Because 2 times 2 is 4. 3 squared would be 9. So our numbers would be 1, 4, 9. That's what an n squared sequence looks like. When we put 4, it's 4 squared, which is 16. When we put 5, it's 5 squared, which is 25. So our next step from here is subtract this from our original sequence, 4, 6, 10, 16, 24. So from here, we get 4 minus 1 is 3, 6 minus 4 is 2, 1, 0, negative 1, right? 24 minus 25 is negative 1. So now we start the process again. So we move the quadratic sequence from our original sequence, and let's see what else there is. So right now my rule is n squared, and maybe there's more, and there is more. Let's take the first difference again. 3 to 2 is minus 1, 2 to 1 is minus 1, 1 to 0 is minus 1, and 0 to negative 1 is negative 1. So that's, again, we took the first difference. If they're all the same, we know it's a n sequence, but in this case our coefficient here is negative 1. So you can write a negative 1, or you can just write that. It means the same thing. How does a negative n sequence look like? Well, again, if I gave you this and I asked you to find the first 5 terms, well, you plug in 1, you get negative 1. You plug in 2, you get negative 2. You plug in 3, you get negative 3, and so forth, right? So I'm going to write negative 1, negative 2, negative 3, negative 4, because if I plug in 4, I get negative 4, and so forth, right? So now my rule here, let me add that part of my rule also is negative 2. Now, let's subtract. So when you subtract, be very careful, because this is not 3 minus 1, it's 3. Now right over here is 3 minus negative 1, which eventually becomes 3 plus 1, which is 4. So 3 minus negative 1 is 4. 2 minus negative 2 is 4 again. 1 minus negative 3 is 4, and 0 minus negative 4 is 4. So basically I'm asking you, what do I do to this sequence over here, negative 1, negative 2, negative 3, negative 4, negative 5, to get 3, 2, 1, 0, and negative 1? Don't I add 4? And negative 5, if I add 4 to it, don't I get negative 1? So 3 minus negative 1 is plus 4, 2 minus negative 2 is plus 4, plus 4, plus 4, plus 4. So this, we're done, and my rule is this. So the rule to this particular sequence, 4, 6, 10, 16, 24, is this. That's the rule of function, right? So again, try it out. On the first term, I should get 4. The second term of my sequence is 6. My third term is 10. My fourth term is 16. My fifth term is 24. So just double check. Let's plug in 5. The fifth term of this sequence should be 24. So that means that 5 squared minus 5 plus 4 should give me 24. 5 squared is 25. Minus 5 plus 24. It is indeed 24. So this checks out. Let's check another one. 3 and 10. The third number in my sequence here, the third term in my sequence should be 10. Well, let's replace that with 3. N squared is 3 squared minus 3 plus 4. That's 9 minus 3 plus 4. 9 minus 3 is 6 plus 4 is 10. Is 10 what we got? Yeah. So this actually is the sequence, is the nth term, right, for this particular series. We had a few more problems. I think this one was that. No. Oh, sorry. Here we go. 1, 3, 9, 19, 33. First difference, it's 2. Plus 2, plus 6, plus 10. And this is obviously plus 14. Let me write first difference. Because they're not the same, I do it again. And then I get 4. I get plus 4, and I get plus 4. So this is a, we stop here, right? We don't have to take another difference. So this is a quadratic sequence. So I know it's going to look like this, n squared. Now, does it have a coefficient? Yes, it does. And where do we get the coefficient? We get it from here. So that 4, we have it. And we get 2. 4 divided by 2 is 2. So that. Now we got to find out what an n times n squared sequence looks like. So again, take that, replace the number 1 for n, the number 2, number 3, number 4, number 5. So we, right? So if I replace that n with 1, I get 1 squared times 2, which is 2. 2 squared times 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. 4 squared is 16 times 2 is 32. 5 squared is 25 times 2 is 50. We're going to subtract that from our original. 1 minus 2 is negative 1. 3 minus 8 is negative 5. 9 minus 18 is negative 9. 19 minus 32 is negative 13. And 33 minus 50 is negative 17. Okay, so I'll write our rule. So part of my rule, I already know it's 2n squared. Now I'm going to start again. Take the first difference. Negative 1 to negative 5 is minus 4. We're decreasing in value. Negative 5 to negative 9 is minus 4. Minus 4. Minus 4. So it's a linear sequence. Okay, so it's going to look, right, line that goes down. Sorry, line that goes down. Slope is negative. So I'm going to take this number over here and put it over here. Right? What does a negative 4n sequence look like? Well, plug in 1, plug in 2, plug in 3. Negative 4 times 1 is negative 4. Negative 4 times 2 is negative 8. Negative 4 times 3 is negative 12. Negative 4 times 4 is negative 16. And negative 4 times 5 is negative 20. We're going to subtract. So I can add here minus 4n is part of my rule. And then, but I don't want negative 4, negative 8, negative 12, negative 16, negative 20. I want negative 1, 5, 9, 13, 17. So how do I adjust this, right? The negative 4 sequence to look like negative 1, negative 5. To that, we're going to add what? So one thing you can do is subtract. So negative 1 minus negative 4 is 3. Negative 5 minus negative 8 is 3. 9 minus 12 minus negative 12 is 3. Negative 13 minus negative 16 is 3. Negative 16 minus negative 20 is 3. So what do we add? We add plus 3. That's my rule here. And again, you can plug in a few numbers. The first term, so the first number, right, I should get 1. The second term of my sequence, when I plug in number 2 here for n, I should get 3. If I plug in 3 for n, I should get 9. If I plug in 4 for n, I should get 19. And if I plug in 5 for n, I should get 33. Let's try 4. I should get 19. So I get 2 times 4 squared minus 4 times 4 plus 3. 4 times 2 is 16 times 2 is 32 minus 16 plus 3. 32 minus 16 is 16 plus 3. Is that 19? Yeah. So when n equals 4, right? When n equals 4, I should get 19. Again, this is more procedural. I have more fun doing the visual, but you should also know this. 11, 14, 19, 26, 35. First difference. 3, 5, 7, 9. Well, it's not linear. We do the second difference. 2, 2, 2. So we know it's quadratic, so it's n squared. Now, what do we do? The coefficient, well, divide 2 divided by 2, we get 1. Do we need to write that 1 over here? No, so we're going to leave it at that, but it's easier. So what does an n squared sequence look like? Well, n squared sequence, the first term would be 1. The second term would be 2 times 2, which is 4. third term would be 3 times 3, which is 9, and 16, and 25. What we do now, we subtract this sequence from our original. 11 minus 1 is 10. 10. 10. 10. And 10. So because they're all the same, right, we don't have to take a first difference. When they're all different, you would take the first difference again, but because they're all the same, we're done. So our rule here, this one is n squared, and literally plus 10. Let's see if that works. So the first term, it's 1, so this the first term I should get 11, the second term I should get is 14, third is 19, fourth is 16, and fifth is 35. So let's take 3. The third term, I should get 19. So when n equals 3, I should get 19. So let's substitute 3 squared plus 10. 19. It works. Let's try again for 1. So when n equals 1, we get 1 squared plus 10. 1 squared is just 1 plus 10. I get 11. So it works. Always try a couple of numbers. So the rule for this one is pretty simple. Just n squared plus 10. So yeah, that's it. 2, 8, 18, 32, 50. First difference. 6, 10, I have no idea, 14, 18. Not linear. Take a second difference. It's a 4, it's a 4, it's a 4. Good. So now we stop there. We know it's a quadratic. What do we, is there a coefficient? Yes, there's a coefficient. The coefficient is going to be 4 divided by 2, so we're going to write 2 over here. What does a 2n squared sequence look like? Well, plug in 1 over here. 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. Really? Let's see. 1 squared is 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. 4 squared is 16 times 2 is 32. And then 5 squared is 25 times 2 is 50. Okay? So we're going to subtract. Subtract is 0, 0, 0, 0, 0. So when they're all the same, you can stop. So our rule, this one is even easier. It stays right there. It's just 2n squared. Let's see if it works. So let's, again, this is my first term, my second term, my third term, my fourth term, my fifth term. So pick any 2 or 3 that you want to confirm. So the third term, when n equals 3, we should get 18. Well, so n times 3 squared. N times 3 squared is 9, and that gives you 18. So that's a check. That works. Let's try 50, 5 and 50. The fifth term, so when n equals 5, you should get 50. So 2 times 5 squared, 25, that's 50. Check as well. So this one is pretty easy. That's your rule, right? So to find any term in this sequence, just plug in whatever term they're talking about, and you find its value. I think we have one more. Ah, you got the easy ones. 9, 2, 9, 22, 41, 61. Okay. First difference. 7. I got 13. 19. Wait, is that right? Yeah, and this one is 25. No, hang on a second, guys. That's 7, 9, 2. That's not correct. 22 plus 19, 6, 4. There's something wrong. I wrote something wrong here. The difference here is 20. I think I wrote something wrong here, guys. So can you just let me double check here again. I copied the last number incorrectly. 7, 13 and 9 is 22. 141, 41, this should be, oh, this is a 6, right? This is a 6, and this is a 6, and not for this, it should be 25. Sorry, hopefully you're watching the video. So if that's 25, this should be 67. 66, sorry. Okay, so that should have been, instead of 61, that should have been 66. Okay, my apologies. That's the second difference. So we know it's a quadratic sequence. So what do we need? We need to see if there's a coefficient, and there is. We divide 6 by 2. You get 3. And part of our rule of our answer is going to include 3n squared. So what does a 3n squared sequence look like? Well, substitute. 1 squared is 1 times 3 is 3. 2 squared is 4 times 3 is 12. 3 squared is 9 times 3 is 27. 4 squared is 16. 16 times 3 is 48. And 5 squared is 25 and is 75 over here. When we subtract, right, we get negative 1, negative 3, negative 5, negative 7, and we should get negative 9 here. So let me write rule 3n squared. There's a little bit more to come. We're going to find the first difference again. Negative 1 to negative 3 minus 2. Negative 3 to negative 5 minus 2. Minus 2. Minus 2. So that tells us that there is it's a linear sequence. But what kind of linear sequence? Negative 2. A negative 2n sequence. Let's find out what that looks like. Substitute 1, you get negative 2 times 1 is negative 2. Negative 2 times 2 is negative 4. Negative 6, negative 8, negative 10. Well, that's not what we want. We actually want negative 1, negative 3, negative 5, negative 7, negative 9. So we have to adjust our negative 2n sequence to get those numbers. So let me just put this. So let's subtract negative 1 minus 2. So remember, it's negative 1 minus negative 2. And negative 3 minus negative 4. So negative 1 minus negative 2 actually becomes negative 1 plus 2, which is 1. And this is also 1. Negative 5 minus negative 6 is 1. Negative 7 minus negative 8 is 1. And negative 9 plus, minus negative 10 is 1. So, and there's our last item. So again, that's our rule. My first term, my second term, my third, my fourth, and my fifth. So just confirm, pick any two. Let's just pick this one. My fourth term should be 41. So if I plug in 4 in here, I should get 41. So let's do that. 3 times 4 squared minus 2 times 4 plus 1. That's 16 times 3, which is 48. 2 times 4 is 8 plus 1. 48 minus 8 is 40. Plus 1 is indeed 41. Okay? Hopefully that helped. I'm sorry about the mistake the last time.